Hey friends, what we're doing today is looking at the TTR and a small little problem we've got. I was fitting a speedo up onto it because we're trying to get this thing ready for roadworthy. Ignore the cracked screen, that's a completely different story. But we fitted it up there on a bracket. Just did a little bit of bending and some mounts up there, and found a new speedo cable for it. And that comes down here to the wheel where there's normally a speedo drive. What I found is that when it was all fitted, it was spinning the wheel and the speedo wouldn't work. So a bit of a process of elimination. Grabbed the speedo cable up here and got that all up in. Just push it back in there to line up. And I'm not sure if you can see that, but it is in fact moving when I spin that speedo cable. Don't quite have the fingers to spin it quick enough, but yeah, I think you can see that. It is moving ever so slightly. So it says the speedo's okay, it says the speedo cable's okay, but it seems so there was something up with the speedo drive. Now if you have a look in there, you can see a bit of rust and corrosion and gunk and all that, and that's probably going to tell you what the story was. Now I've already had a bit of a look at this, and this is the speedo drive, and that lives down here, something like that, and these three little nubs there sticking out of the wheel hub drive these three little teeth. Now when we're looking at that, it all seems quite clear. I took this apart a few minutes ago and it was all just covered in gunk, and it seems as though that outer ring there is meant to sit on a couple of little flat surfaces on the drive gear in there. I'll take it apart so you get a better see. Alright, so I brought it inside where we've got a bit of better light and we can see what's happening in here. This piece here is meant to go on here. And there's two little flat surfaces that have been machined on that gear there. One just in here and one here. And this little ring, once upon a time, looks like it had a couple of matching flats, probably about there and there, just judging by the wear marks, that would keep that locked in place so that when the gear turns, or more to the point, when the three-spoked ring there turns, the gear would turn. A little corresponding gear up in there gets turned, and that would spin the cable and get the speedo spinning. So I was thinking there's a couple of things we could do to fix that. One would be to just get a little welder out and maybe weld those flats back up, file them up, reshape it. Then I thought maybe we could cut another one of these plates from scratch out of a bit of steel. But I figure it's kind of a sacrificial piece. It's the bit that we want to fail, and it'd be great to maybe have a few replacements of them. So I thought, why not put one of these 3D printers I got kicking around to good use. The idea is that I want something almost exactly like this little black piece here that's going to go sit on top of that there and replace this this metal tri-spoke washer. And you can see this piece here, it's got the same matching flats on there, a flat surface there and a flat surface on the other side, and that lines up with the little flat surfaces that drive this gear here. And the way that I've done it is with a cool little program called OpenSCAD. OpenSCAD or OpenCAD or OpenSCAD, yeah. And the way I've gone about it is what I usually do, because I don't know it very well. So I started off with their examples, and here's like a bit of a demo file that they've got, and they've got a few different shapes in there. And I've stolen a few ideas out of the way that they've made those, copied them across into my own file. You see I've started off by extruding out just a bit of a tubed shape there with a little lip on it. That lip corresponds with the with that tiny little step there at the top edge. And then after I've done that, I've gone and added in a tab. And I'll just do this step by step so you can sort of see the process I went through to make it. So the first thing I did was add in a tab, and you can see now we've got one tab on it. So from there I just copied and pasted that. I was trying to find a better way of doing that, maybe some rotary spline function, but I just went with the quick and dirty option in the end. You can see we've got those 3 tabs on the edge, but you can see we still don't have those flat drives on there. So just a couple more lines in there. We go in and uncomment that, rerun it, and you see now we've got those drives in there. So export that model out, bring it over into what they call a slicer. That takes that model and then turns it into a bit of code that the 3D printer can understand, and copy it onto an SD card and take it across to the printer. Then we play the really fun waiting game as it does its thing. So it hasn't quite gone to plan. The print quality is looking pretty good. Seems to be quite solid and quite firm. I don't know yet whether or not I've measured incorrectly or the calibration's out on the printer, but she don't fit. So just a little bit too tight. I can't quite squeeze that over that edge. And even on the flat side, you can see there it's just a little bit, let's line the flats up at least. It's just a little bit too small. Pretty sure I took the measurements alright, but as I say, this 3D printer's fairly new to me, so I think its calibration might be a little bit out. The measurements that I took, I pretty much relayed straight into the model. So yay for 3D printers. I've just done some measuring on this, and in both the X and the Y direction, that inner edge there is 25.2 on the printed part, but I'd spec'd it at 26.1. You can see up here I've called that diameter SD at 26.1, which is what I was expecting it to be, which says that something's probably going on with the 3D printer for it to come out small. However, the height dimension is spot on at 6mm, so pretty happy about that. That means that the calibration on the Z dimension, or the vertical dimension, is okay. It's just going to be the XYs that need to be calibrated by whatever the difference is between that 25 and 26. All right, with the help of a calculator, it's told me that that's we're going to need to change the value by or multiply it by 1.03. So up on the this printer here, which I still don't know how to use properly, we're going to come into configuration, and we're going to come down to where are we? Advanced settings, and steps per millimeter. And we're just going to multiply that 78.7 by that 1.03, and that's going to give us 81.5. Now going by our measurements before, both axes had the same amount. Now I'm going to just hit this store settings option. If it was something a bit more risky, I might do the test print first, but I'm fairly confident that this one's going to be good. I think that beep means it worked. Just wait and see. Kick off another print and let's hope for the best. So we've got a finished part. Made a couple more changes to it and had a couple more prints. I think we're up to iteration 6 or something now, and we've got a pile about that big worth of failed prints. But all that matters is I think we've got something that's going to work. A couple of changes I made were just decreasing the lengths of those little tabs there. After we increased the scaling of the X and Y steps before, they ended up just being a little bit too big to fit in behind the dust seal there. But now they should fit in there quite nicely. Sneak past that seal. And also decreased the width of the ring, so between here and here. Dropped that by a millimeter as well. I was just looking at it, and I must have mismeasured something on the original part. Just didn't look quite right. Didn't look like there was going to be enough room for the corresponding teeth on the wheel hub to slide in there. So just made a few little changes. So when I took this apart, and I'm hoping if there's any ttr250 owners out there that have been down this path before, both of these washers were on the bottom there, and I just don't think that was right. So I'm going to put it together a bit of a different way and just hope that it works. It just seems to fit with my sort of mechanical sympathy a little more, and that drops in there. And then I'm going to actually put this washer on the top there. Now somewhere in the shed on the floor there's going to be a little snap ring that pops into that groove and stops everything falling apart. It's got some lithium grease here. Going a little bit generous on that. I figure it's probably going to pull up a fair bit of that dirt that's still in there. So if there's plenty of it, the dirt should work its way out a bit easier. And click. Alright, moment of truth. Let's put it on this bike and see if it works. Good sign. unfortunately I've had to take it back out again. It seems that the drive there is working okay. The teeth are engaging and they're spinning the gear around as you'd expect. But the little gear that goes down in the side here, up in there, for some reason it's got a lot of play in it, so as it moves backwards and forwards it kind of like cocks in place and then locks this up, and then stops it from spinning. So I'm hoping, as you can see, it's fairly grotty and it needs a good clean. The other thing I noticed is that this piece here, which retains the pin, and also where the bit screws in, you can see there's a bit of dirt in the collar there. This wasn't pressed as far in as what it should have been. So the fact that wasn't in is probably why this was able to move backwards and forwards and not do what it was supposed to do. So, alright, so after taking the speedo drive apart 4 or 5 times, cleaning up a whole heap of the rust, etc., melting out one of these, trying to spin it with the drill, printing another one, and finally refitting it. We've finally got it all working. The other one of these that I printed was pretty much exactly the same, just in a different color plastic. The dimensions were all the same. The gear inside there, when I took it all apart and wire brushed it all back, they're fairly pitted and rusted, and I really don't have a lot of confidence in them. Sort of, as you spin them around, they feel really rough and bindy in spots. So I have a feeling that, before too long, it's probably going to bind up down the road somewhere and just strip the teeth off that plastic, or maybe not strip the teeth, but probably strip the same flats that we saw on the steel washer wear out. But we'll wait and see, and it's at least a cheap fix if it happens again, and I'll keep my eye out for another speedo drive. So I hope you found this interesting. It's been a bit of fun. When the new speedo comes in, I'll fit that and probably look at wiring those up into this plug here. So if you're interested in that kind of stuff, let me know. Or if you want to know more about the computery 3D printy stuff, yeah, just let us know and I'll do more on that. Catch ya.